Good code hygiene is like washing your hands. It might seem like a hassle, but washing your hands with soap and water is highly effective at preventing the spread of disease. Similarly, good coding style is highly effective at reducing the chance of bug escapes. To this end, your code should be modular. There should be many small source files rather than one huge main.c program file that is thousands of lines long. Ideally, there's a separate .c or .cpp file for each class or cluster of functions in the system. C code doesn't have the class keyword, but you can still do a similar thing by grouping like functions and like data structures together into separate .c files. For example, put a struct or typedef data definition along with its initializers and access methods into a single .c file, but nothing else. Only externally visible declarations should be stored in a separate .h file paired with each .c file. Conditional statements are a source of significant complexity and must be made as clear as possible. Each conditional clause should have a Boolean result. For example, if you want to test whether an integer is 0, you should compare that integer value to 0 rather than relying on the C language characteristic of treating any non-zero value as true. Additionally, conditional clauses should have no side effects, including no assignments. All switch statements should have a default clause, and in most cases that default should be an error trap. If nesting should be limited to manage complexity. This is discussed further in the tutorial on cyclomatic complexity. Variables should have descriptive names that differ significantly from each other so that it is difficult to confuse them. Each variable should have the smallest practical scope of visibility and should, in general, never be globally visible. Variables should be initialized at the point of definition to reduce the effort required to check whether the variable is potentially uninitialized. The strongest typing information practical should be used to keep variable types straight. At the very least, the C language portable integer size types such as uint32_t should be used to make variable sizes explicit. This is especially important in small embedded processors where default sizes for integers might be changeable or might be other than the 32-bit integer size that desktop programmers are used to. Generally speaking, beyond that, more typedefs are better for keeping straight what's going on in terms of data typing. Interfaces should check the ranges, balance, and sanity of the variable values passed to them, including buffer overflow checks and more. Finally, many functions return error codes that are ignored by the calling function. This is generally a recipe for a system that behaves in an unpredictable way when something unusual goes wrong.